Hello everyone. Today we're going to continue with probability theory. Exercises of sigma algebra. We have to solve exercise number 4 and exercise number 5. So here we go. Exercise number 4. Let omega 1 and omega 2 be arbitrary sets and let x be a function from omega 1 to omega 2 where f2 omega 2 is a measurable space. Prove that the following collection is a sigma algebra of subsets of omega 1. X minus 1 of f2 is equal to set composed by the primacies of elements in f2. It's a fairly and powerful result for the probability theory. This is used in topic of the random variables. Implicitly, f2 is a sigma field or sigma algebra of omega 2. X minus 1 of f2 is a collection of subsets of omega 1 such that number 1, by definition of sigma algebra, omega 2 is in f2. Then the primash of omega 2 is in this collection. And we know that this equality it's true. Then omega 1 is in this collection. Number 2, A is an element of this collection that means exists B1 in F2 such that the primash of B1 is equal to A. Then the complement of the primash of B1 is equal to A complement. Using properties of the primash, we have that the primash of the complement of B1 is equal to A complement. B1 is in F2. Then pardon, it was my mistake. B1 complement is in F2 by definition of sigma algebra. Then the primage of B1 complement is in this collection. By this, a complement is in this collection. Subsection 3. A1, A2, subsequently, are elements, pardon again, of this collection. Then exist B1, B2, subsequently in F2 such that A1 is a primage of B1, A2 is a primage of B2 subsequently. These are elements of F2. So we have this union is in F2. Then the primage of this union is in F2. Then using other property of the primage, we have that the union of the primages is in this collection. Then by this, the union of ANs is in this collection. Now, exercise 5. Let T be an arbitrary set different of empty sets. Supposed to for all T and T, it has a sigma algebra of Ft of subsets of omega prove in detail that this intersection is a sigma algebra of omega. Number 1. Omega is in Ft for all t and t by definition of sigma by hypothesis. Then the intersection of t and t of Ft has omega. Number 2. A is an element of the intersection. Then A is in Ft for all t and t. By definition of sigma algebra, a complement is in Ft for all t and t. And we have that a complement is in this intersection. Number 3. This subset, well, this is a sequence of events is a subset of this intersection. Then the sequence is a subset of Ft for all t and t. Then, by definition of sigma algebra, this union is in Ft for all t and t. And finally, this union is an element of this intersection and is shown. Okay, thanks for watching, and I'll see you later in other video.